cor for correlation function, and the LM for linear models or regression function. So first things first, we're going to, again, load our student survey data set. There are a few continuous variables here, and for regression and correlation, we are going to need two continuous or quantitative variables. Couple options. I think today we will look at verbal SAT and GPA. So we can consider the correlation function, again looking at the manual page. This one is similar to the variance between two functions or covariance, but we're going to be interested in correlation. So for correlation, we want to enter x for one variable and y for a second variable. So we can consider here the correlation between student survey, and we will select verbal SAT, and then we will do student survey again, and this time we'll do GPA. Now, if you just run correlation, many times for most data sets you're going to get an NA value. This is because the default is that R is going to try to find the correlation using every possible value. And if we come and take a look at our GPA variable, we will see that some GPA values are missing. And as R does not want to mislead you and give you results that it's not sure of, it's going to return missing as well. So oftentimes what we can do is set this use argument, and we're going to do use equals, and instead of everything, some options that we have, if we take a look down here, all obs, complete obs, NA or complete, or pairwise complete obs. And this is often one that we will use, as it will only consider situations where we have both observations so that we can find the full correlation. So if we run this here, now we get a correlation of 0.353, so a little bit above 0. We've got a positive correlation. How strong that is, that's up for interpretation. Now another function to go along with correlation is core.test. Now core.test, we can enter in all of the same values that we had before, and now if we run this, it's going to run a Pearson's test for correlation. So we'll get our t-value, degrees of freedom, and we'll see that the sample correlation is estimated as well. Alright, so this is for correlation. Do two variables have a linear relationship? Now, what would be good to do before this is to actually plot these two functions to see what they look like in general. And so we will throw this up here really quickly to take a look. And so we can see there's definitely some scattering here. We're going to see kind of distinct values because SAT and GPA are likely to take on a set of distinct possible values. So we can see that, but we do see perhaps an upward trend, so perhaps a positive correlation is not out of question. Now for a regression model, we're going to use the LM, which stands for linear models function, and similar to before, we're going to use a formula approach, and we'll also use the data argument. So I'm going to run LM, and perhaps we want to predict GPA based off of verbal SAT score. So I will specify that this is the student survey data set. Now if you just run this function, similar to other things, you're going to get a little bit of output. You'll get the estimates for the coefficients, your intercept, or often we say B0 term, and your slope term for SAT. And so we could interpret this and say for every 1 point increase in verbal SAT, we would expect the GPA to be 0.001893 points higher. And our intercept term, this is a case where perhaps this isn't the most useful. We would expect somebody that scored 0 on the SAT to have a GPA of about 2.03. Now, running the linear model may be useful, but what tends to be more useful is to run it, save it, and notice now we aren't going to get any outputs here, but we want to use, similar to what we did with the AOV function, two additional functions to extract some more useful information. And similar to the AOV function, they are the summary function, which will give us a full table with a little bit of information, but perhaps most useful is our coefficient table, giving us once again our estimates, as well as standard errors and the resulting t-test and p-values. There's a little bit of information down here for overall model fitting that we can use primarily for multiple variable regression, where we have multiple predictor variables, but you can see those results there. And then we can use the plot function to once again test our assumptions, similar to what we do with AOV. And this process follows the same. So here, I'm going to fit this. Now, for our linear regression models, we don't want to see any sort of overall pattern. Now, we might be a little concerned we don't see as much spread on the high or low ends, but in general, one might look at this and say, okay, in general, this looks fairly well spread out, perhaps just low observations on the low and high ends. Then for our second plot, we want to check normality. This line appears to follow the line fairly well, a little bit down on the bottom and again on the top, but perhaps we would feel okay doing these. Now again, there are two additional plots. We have not been paying much attention to those. They are available when again looking somewhat at the spread of the residuals or the errors in the prediction. And then the final is for something we call leverage. These are fairly commonly used, but are not a big focus in our class. Okay, so that is the correlation and the LM functions or the core function rather, sorry, and the LM function to calculate correlation of two continuous variables or to fit a linear regression model. Now remember, one final note here for the LM function, do the value you are wanting to predict, then your tilde, and then the value that you are using to predict this response variable. So our predictor variable on the right side and our response variable on the left.